Hello everybody, getting ready to do lesson 8.2 part 2 classwork for pre-calculus math today. And 8.2 part 2 here, you got 6 points goes into your notebook. 32 points will go into your classwork sheet. Students, put your name, date, period. Homeschoolers, online students, put your due date here. Let's start out. Let's go right into it today with a notebook entry here. The sum of a finite arithmetic sequence. There is a simple formula for the sum of a finite arithmetic sequence. The sum of a finite arithmetic sequence with n terms is given by Sn equals n over 2 multiplied by a1 plus a to the n. Be sure you see that this formula works only for arithmetic sequences, so there has to be only arithmetic for this. Let's try it now. In example 5, finding the sum of a finite arithmetic sequence. Here's your sum here. So to begin, notice that the sequence is arithmetic with a common difference of 2. Moreover, the sequence has 10 terms, so the sum of the sequence, s to the n of this, would be n over 2 times a1 plus a to the n. Formula for the sum of the arithmetic. And then find this sum for that. So 10 over 2, we got 10 sums. 1 plus 19, substitute 10 for n. 1 for a to the 1, and then 19 for a to the n. And then when you do your arithmetic here, you come out with 100 for the sum of that. Okay, let's find the sum of this. So how do we do that? Well, how many have we got here? We got s to the 10, so again we go 10 over 2, then 2 plus 20, 2 plus 20, and which will come out to 110 now. And 22 times 5 will be 110. Students, this is up to you. So the sum of the first n terms of an infinite sequence is called the nth partial sum. So if we have n terms of an infinite, then it would be the nth partial sum. The nth partial sum of an arithmetic sequence can be found by using the formula for the sum of a finite arithmetic sequence. So knowing that, finding a partial sum of an arithmetic sequence, find 150th partial sum of this arithmetic sequence there. So for this arithmetic sequence, you have a to the 1 equals 5. That's your first term. And then our d would equal 11. We have a difference of 11. So a to the n would equal 5 plus 11 times n minus 1. And the nth term is a to the n would be 11n minus 6. Therefore, we plug in 150 for n. We get 11 times 150 minus 6 would equal 1644. And the sum of the first 150 terms is nth partial sum formula. 150 over 2 plus 5 plus 1644, and we plug in now 150 for n, 5 for a to the 1, and then 1644 for a to the n. So the sum for up to that point would be 75 times 1649, which comes to 123,675. Let's try one now. Find the indicated nth partial sum of the arithmetic sequence. So n equals 10 would be our sum of that. So when we add up to 10 here, n equals 10, we get our formula down here. 10 over 2, 8 plus 1, 16. So a to the 1 equals 8. A to the 2 would equal 20, so we have a difference of 12. So a to the 1 plus 9d would equal a plus 9 times 12 would equal 116. So now we can plug that back into our formula now. 10 over 2 over 8 plus 116 would equal 620. So up through n equals 10. And then do the same down here, students, for your own independent practice. And what do we do here? Total sales. So a small business sells $20,000 worth of sports memorabilia during its first year. The owner of the business has a set goal of increasing annual sales by $15,000 each year for 19 years. Assuming that this goal is met, find the total sales during the first 20 years. This business is in operation. So the annual sales form an arithmetic sequence in which 8 to the 20 is 20,000. And then our D will be 15,000. So 8 to the n will be 20,000 plus 15,000 times n minus 1. And the nth term of the sequence is 8 to the n will be 15,000 n plus 5,000. When you multiply through by that, and then we combine like terms, we come up with this expression here. So this implies that the 20th term, when you plug in 20 now for n, we get that expression there, and 300,000 plus 5 is 305,000. The sum of the first 20 terms of the sequence is the nth partial sum formula. So 20 over 2, and then 20,000 plus 305. So 20 for n, 20,000 for a to the 1, and 305 for a to the n. And then what does that come out to? 10 times 325, that comes to 3.25 million. And so the total sales for the first 20 years are 3.25 million. Use the list editor of your graphing calculator to create a table that shows the sales for each of the first 20 years. So here would be in your table. And the total sales for the first 20 years is shown, and that comes out with that number as well. So we got a problem here. Hardware store makes a profit $30,000 during its first year. The store owner sets a goal for increasing profits by $5,000 each year for 20 years. Assuming that this goal is met, find the total profit during the first 5 years of business. So our a to the 1 here would be 30,000. That's what we start with. Then a to the 2, this will be our formula here. 30,000 plus 5,000 equals 35,000. And then I'm going to leave this up to you, students, to finish that. So in this figure here that we show in this slide, it shows the annual sales for the business in example 7. Notice that the annual sales for the business follows a linear growth pattern. In other words, saying that a quantity increases arithmetically is the same as saying that it increases linearly. So here's your linear progression here, your linear increase that follows the business example 7. If you go on to take a course in calculus, you will study sequences and series in detail. You will learn that sequences and series play a major role in the study of calculus. Okay, so that's 8.2 part 2, pre-calculus math. Here's my email, animatedpowerpointmathvideo@AOL.com. Thank you.